Welcome to the session on radians, areas of sectors and segments. The objectives for this session are to find areas of sectors and segments using radians. Using radians simplifies the formula for the area of a sector. The area A of a sector of a circle is A equals a half r squared theta, where r is the radius of the circle and theta is the angle in radians contained by the sector. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. We are required to calculate the area of the sector of a circle of radius 3.5 centimeters, given that the arc subtends an angle of 2.3 radians at the circle center. So let's solve this. From the formula, we have that the area of the sector is equal to a half r squared theta. So if we substitute in the values, namely radius equals 3.5 centimeters, or r equals 3.5, and theta equals 2.3 radians, we obtain that the area of the sector equals 14.09 centimeters squared to 2 decimal places. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. The area of the shaded sector in the diagram is 35.7 centimeters squared. Given that theta equals 1.2 radians, calculate the value of r. The area of the sector is equal to half r squared theta, as given by our formula. And so, if we plug in the values, we have that the area of the sector is 35.7 centimeters squared, and this equals a half times r squared times theta, which is 1.2 radians. And so rearranging the formula gives us that r squared equals 59.5. So square rooting gives us r equals 7.71 centimeters. Of course, we don't take the negative root because radius cannot be negative. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. The radius of a sector of a circle is 50 centimeters. Its perimeter is 135 centimeters. Find the area of the sector. Now the arc length L, as shown in the diagram, is equal to 135, which is the perimeter, minus the 2 radii, or radiuses. Each of the radiuses is equal to 50 centimeters, so therefore L is equal to 135 minus 50 minus 50. And this is equal to 35 centimeters. We know that the arc length L is equal to r times theta, and therefore 35, the arc length, is equal to 50, which is the value of the radius, times theta, which is what we're required to find, before we can find the area of the sector. Rearranging this gives us that theta equals 0.7 radians, and therefore the area of the sector equals half r squared theta, in our example, is equal to a half times 50 squared, which is radius squared, times 0.7, which is the value of theta. And this gives us that the area of the sector equals 875 centimeters squared. We are now going to find the general formula for the area of a segment. The area of a segment, as shown in the diagram, can be found by subtracting the triangle OPQ from the sector OPQ. The area of the sector, as we know, is equal to 1/2 r squared theta, and it's denoted by the shaded region. The area of the triangle is equal to 1/2 AB sine theta, and this is also shown by this shaded region here. The area of the segment in a circle of radius r is A equals 1/2 r squared theta, which is the area of a sector, minus 1/2 r squared sine theta, which is the area of this triangle. Factorising gives us that A equals 1/2 r squared times theta minus sine theta. Let's now summarise our formulas. We have that the area of the sector is equal to 1/2 r squared theta, where of course r is the radius of the circle and theta is the angle in radians contained by the sector. And we also have that the area of the segment equals 1/2 r squared times theta minus sine theta. We will now apply this to another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. In the diagram, OPQ is a sector of a circle radius 3 centimeters. The chord PQ is 4 centimeters long. Find the area of the shaded segment. We're going to begin by calculating the angle POQ. Recall the cosine rule for a non-right-angled triangle. We've plugged in the values b equals 3, c equals 3, and a equals 4 into the formula for cos A. Calculating this gives us that cos of the angle POQ equals 0.1 recurring. And therefore, if we inverse cos this value, we obtain that angle POQ equals 1.45946. So plugging in the value of r and of theta gives us this expression here. The area of the segment equals 1/2 times 3 squared, where the radius is 3 centimeters, times 1.45946 minus sine 1.45946. And therefore, the area of the segment equals 2.095 centimeters squared to 3 decimal places. This brings us to the end of this session. If you have understood its contents, you should be able to find areas of sectors and segments using radians. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.